Okay, so here we're going to find, I guess, all different quantities that we're concerned with about circles, which means radii, diameters, circumference, and areas. All right. Now, for the purposes of this worksheet, I am going to be using pi as the approximation of pi 3.14. So if you use the pi button on your calculator, or you may use extra digits of pi, you're going to find your answers differ slightly from mine. But that would be a trivial difference. I wouldn't be concerned with that. All right, so question one. The first thing we want to do is we want to label the radius of a circle, the diameter, and the circumference. So we don't need to measure anything. We're just going to draw these guys in. Okay, so I'm going to draw in a radius first. So a radius is the distance from the center of a circle to the edge. That's the radius. Now, I could also draw this in this angle, or really at any angle. In fact, any direction from the center to the edge would be a radius, and that would be the same distance, actually. That's one of the definitions of a circle. All right, next we'll do a diameter. So diameters go all the way across a circle. And again, just like the radius, that could have been drawn in any which way. The direction and specific angle that I drew that diameter is actually irrelevant. I'm going to label this like that, diameter. Right, great. And then the circumference, distance all the way around a circle. Okay, so there's a couple of ways to do that. I'm actually going to draw a little set of arrows to indicate that the circumference goes all the way around this edge like that. All right, and I'm going to label it along the edge here, circumference. Great, okay. Well, that's not the most pretty circle, but I think it'll do for our purposes. All right, so we're going to start off with some softballs here. Question 2 is find the diameter of the following circles. Okay, so if we look back, we know that we've defined diameter, which would be the distance all the way across a circle. And one thing we notice is that, well, if a radius is from the middle to the edge, I could go in that way to make a radius, or I could go from the middle this way and make a radius. And so the diameter is 2 radiuses, which actually we say radii if you want to know the official terminology. So in other words, the diameter is 2 times the length of the radius. It's twice as long. Okay. So to find the diameter of a circle, well, that's going to be 12 meters along here, plus another 12 meters along here. So together they're going to make 24 meters in total. 12 plus 12, or 12 times 2. All right, now if we move to this diameter again, this radius here is 3.6 centimeters, so I know another radius along here will be another 3.6 centimeters, and together they will be 7.2 centimeters, or 3.6 times 2. All right. Now we move on to a question they're asking now for the radius of a circle. Okay, well, I mean, now we're just going in the opposite direction. If the diameter is twice the radius must be, well, I guess we're given a diameter here, so we're going to cut that in half. We're going to imagine, well, what's half of the way to 7? If you go halfway, well, you've gone 3.5 or 3.5 millimeters, and that's half of 7. So the radius is 3.5 millimeters. Similarly here, I've got a 11.2 kilometer diameter all the way across a circle, so halfway is my radius, and so that must be half of 10 is 5. And I've got 1.2 left over, so half of that is 0.6 kilometers. And so the radius must be 5.6 kilometers. All right, great. Moving on. Okay. So question 4 asks us for the circumference of the following circle. Okay, well, now it's going to look like we're going to need to know some formulae. Some formulas are written on the front of our worksheet, and these are all the important circle formulas, almost. And so actually, I think I've got a copy right here. Perfect. So actually, I've got a nice purple formula sheet with all my circle formulas right here. I'm going to be referring to this as we're on other pages, so I'm not flipping back and forth. All right. Okay, so to find the circumference of the following circles. Okay, so to find the circumference, and what was the circumference again? It was the distance all the way around. Okay, so, you know, it doesn't hurt to take a second to maybe make an estimate. How many times could I set this radius around the edge? Well, I don't know. Like maybe if I counted radii, I can imagine laying one along here be 5.2, and another one might be 10.4, another one 15.6 or 15. So maybe, I don't know, maybe around 30 meters in total if it's 5.2 from here to here. Maybe a little less. I think it's a little more actually. Okay. All right, so to find the circumference, I need to look on my formula sheet. And I see circumference is equal to 2 times pi times the length of the radius. All right, that should be easy enough. So I'm going to say, okay, my circumference is 2 times, and for pi, I'm going to use 3.14, just for simplicity's sake. And the length of the radius of this circle is 5.2 meters. Okay, so it's 5.2 meters. All right, and I'll just put that into a calculator. And I say that 2 times 3.14, oops, 4 times 5.2. All right, and that gives me 32.656 meters. I'm going to keep all my decimals today, but usually I'm in the habit of rounding. All right, so we'll write that in here, 32.656 meters. All right, now, okay, so we're probably going to end up using the same formula for this circle, 2 times pi times the radius. Okay, and so we're going to just punch in some numbers here. 2 times, instead of pi, I'm going to write 3.14. And the radius is, well, actually, we're not given the radius, but we are given the diameter. And we saw in an earlier question that if we know the diameter, then, well, we can find the radius. The radius must be halfway. So what's half of 21? Half of 20 is 10. Half of 22 is 11. So half of 21 must be 10 and a half. And it is 10.5 millimeters. Okay. So here I'm going to punch in, instead of the radius, I'll put in just 10.5 millimeters. All right, and that will all equal some distance. 2 times 3.14 times 10.5, and that gives me a circumference of 65.94 millimeters. Now, I did a little bit of extra work there, and the reason I did that is because I wanted to make sure we're maybe only using one formula, but however, if you feel like you're getting the hang of this and you think you can handle a second way to calculate the circumference, you can know that the circumference is actually just pi times the diameter as well, because the radius times 2, which we do in the circumference formula, is actually the same thing as saying the diameter. So if I am already given a diameter of 21, I could have actually said, well, I'm just going to say 3.14 times the diameter of 21 millimeters. And let's just make sure that gives me the same value. If it doesn't, then we're in trouble. 3.14 times 21. And yeah, it gives me 65.94 millimeters. Okay, so that was kind of handy. All right, so this question is labeled a challenge. Now, I think a lot of you guys are up for this. I'm going to write the answers in it anyways as we go. So, okay, here we're asked to find the radius. Okay, but what are we told? We're actually told the distance all the way around, the circumference, is 46.4 centimeters. Okay. Well, I'm going to use the equation that the circumference is equal to 2 times pi times the radius, which we used earlier, And just as before, I'm going to punch in everything I know. It just happens that what I know is going to be punched in on both sides of the equation. So I know the circumference is 46.4, so I'm going to replace circumference with 46.4 centimeters. Actually, maybe I won't put the units in just to not get confused. I'll say equals. I'm going to add the units in afterwards. And 2 times, instead of pi, I'll write 3.14 times the radius. The radius is our unknown. Okay. Well, this actually looks a lot like algebra. If I want to get my radius by itself and discover its value, I'm going to need to get rid of these other terms that are bothering it. So what I'm going to do is I'm going to perform the opposite operation on both sides of the equation. I'm going to do this in 2 steps, although maybe you can think of a way to do this in 1 step. So what I'm going to do is I'm going to say, well, 2 is being multiplied by this value, so I'm going to divide by 2 on both sides of the equation. And divided by 2 and multiplying by 2 are opposite operations, so that leaves me with just 3.14 times the radius over here. And at half of this, looks like it actually divides quite nicely. Half of 4 is 2, half of 6 is 3, and half of 4 is 2. Okay. And the same operation looks like. We're multiplying by pi, 3.14, so I'm going to divide by pi, 3.14 on both sides of the equation. And again, these cancel out, leaving me just with an r isolated over on the right-hand side. And on the left, well, that's definitely a calculation I can't do in my head, so I'm going to bring in my calculator. I'm going to say, okay, well, that's going to be 23.2 divided by 3.14, and okay, this is definitely a case where I'm not going to write all the decimals. I think I'm going to round it to 2 decimals. Okay, so let's say that's 7.3, and I will cut off all of the decimals to the right of that 8. But I need to ask, is this 8 bigger than 5 or equal to it? And it is bigger than 5. So that means instead of 7.38, I'm going to round that up 7.39. 7.39. And what were our units? Our units were centimeters. Centimeters. And that's how long the radius is. So we had to use a bit of algebra in order to find the radius. But very doable. All right, let's see if we can do that again. Okay, 2 pi r, that's all equal to the circumference. I wrote it backwards, and it doesn't really matter what order you put things on an equation. All right, so 2 times pi times r, so it's 2 times 3.14 times. Again, the radius is unknown. We are given the circumference, so I'll just leave the radius there. And say the circumference is 120.5 meters. Okay, so I'm going to divide each side by 2. Again, you know what? I'm actually going to, let's do it in 2 steps. Okay, divide by 2. So that leaves me with 3.14 times the radius. And that looks like it's going to be equal to half of 120 is 60. Half of 5 is 0.25. Pardon me, half of 0.5 is 0.25. And maybe I'll get rid of those units for now. Okay, then we'll divide by 3.14, we'll divide by 3.14 again. Again, we're doing the opposite operation of multiplying by dividing, and by doing that, we cancel out. And then we got 60.25 divided by 3.14, and it tells us that our radius is 19 point, oh, round to 2 decimals again, so it's 1, and again, the number to the right of that 8 is bigger than 5. So that means I'm going to round that 8 1 up, 1 higher, and make it a 9. Or my units again, my units were in meters, so that will be the length of the radius of a circle. That's 120.5 meters all the way around. Okay, so that was a little harder, but not so bad. All right, let's see if we can find the diameter. Okay, so we're told the circumference, and really we only kind of have one equation of a circumference. It says circumference is equal to 2 times pi times the radius. However, I reckon if I can find the radius, I could also find the diameter. So maybe I'll do that. Okay, I'll rewrite this equation. 1,000 equal to 2 times 3.14 times the radius. Now here I'm going to do a fancy trick. I'm going to divide by 2 and 3.14. 2 times 3.14. Divide by 2 times 3.14. And do that in one fell swoop. Now that's a bit of an advanced maneuver. All right, so that'll tell me the radius. So the radius is going to be 1,000 divided by, now if I do this, I need brackets around this whole thing. I need to make sure I'm dividing both of them. So I'm going to open up a set of brackets here. Oops. 1,000 divided by, and it'll be 2 times 3.14. Close bracket, like so. Okay, and that looks like the radius for a circle with a circumference of 1,000 meters is 159.24 meters. Now, of course, we weren't asked for the radius, we were asked for the diameter, so we're going to multiply each of those by 2, times 2, times 2, and that gives me a diameter. And that diameter is going to be 159.24 times 2. So it's going to give me a value of 318.48 meters. And that's the diameter, the distance all the way across a circle. All right. Now, on part B, I'm going to use a bit of a shortcut here. Now, we talked earlier about how the other equation for a circumference is C is equal to pi times D. And we can see how this is actually a uniquely useful formula for this sort of situation. Now, if we're asked for this, we're asked for the diameter, and we're given the circumference, so I can just punch that in. 240.5 kilometers is equal to 3.14 times D. Actually, in this case, because I chose this formula that relates to the circumference and the diameter, I can actually just divide by 3.14, divide by 3.14, cancel, cancel, and we get our D is equal to 240.5 divided by 3.14 pi, and we end up with our distance, or pardon me, our diameter, which is 76.59, I'll round to 2 decimals, kilometers. Like so. Okay. So back to some normal, straightforward calculations. Find the area of a circle. Okay, we need our area formula. So our area for a circle is pi, our circle constant, times the radius squared. Okay. So it looks like they give us the radius here. I'm going to label that the radius to help me keep things straight. All right, and so the area is equal to pi times 6.3 meters, and that all squared. Okay, now squared means multiplied by itself, so if I wanted, I could say pi times 6.3 times 6.3, because that's what squared means. I think I might do it that way while I'm going through these calculations, just to reinforce what being squared really is. So I'm going to write down 3.14 times 6.3 times 6.3. And then I get the area overall is actually 124 point, I think I'll keep all the decimals, 6266. And of course, we're talking area, so that means we're talking in square meters. Okay, 124.6266 meters squared. All right. So maybe we'll move on to B just to keep in order. All right. Similar situation. We got area is equal to pi times the radius squared. Pi times 89 squared. Okay, well, different calculators have different ease with squaring numbers, and this calculator happens to also have a button for squaring. So this time, instead of doing 89 times 89, which is what squared means, I'm actually going to write just pi times 89, and I'm going to press the x squared button, which is right here. Oops, that one there. And I'll press that, and it actually just raises 89 to a power of 2. And I press equals. Okay, and it's a pretty big number this time. So that's 24,871.94 centimeters squared. Dandy. All right, moving on to question C. Okay, well, the area of a circle is for sure pi times r squared. This is not the radius, so we want to be careful for that. This is what? Well, it's the diameter, the distance all the way across. So the radius must be half of that. It must be half the distance. So the radius is, let's label that a diameter, and the radius is going to be half. And actually that looks like it divides nicely in half. So half of 2 is 1, half of 4 is 2, and half of 4 is another 2. And it's in centimeters. Great. Okay, so then we're going to find the area, and that's going to be pi 3.14 times 12.2 squared. And to be squared means to be multiplied by yourself, so I'm going to do it long form this time. 3.14 times 12.2 times 12.2, and we'll just see what that gives us. Terrible. 3.14 times 12.2 times 12.2. And we end up with 467.3576 units centimeters squared. Again, just to remind us, if this is 1 centimeter, a square centimeter looks like this. That's 1 centimeter by 1 centimeter, and that's a centimeter squared, and that's what we're really counting here. I'll make that a nice 1. Okay. And so obviously this circle is not to scale, but if it was, we could fit 467 of these square centimeters inside it to cover up that area. All right, last one. Area, and that's equal to pi times the radius squared. Okay, obviously the radius is half the diameter. We're probably getting that pretty good by this point. So the radius is 30 meters, and we got an area is pi times 30 times 30. Okay, so the area is pi times, well, I can multiply these together in my head. I know 3 times 3 is 9, and I know this trick when I multiply numbers with zeros at the end. I just count the zeros after them. That's 2 zeros. I'm just going to add them right onto the end. So it actually becomes 900. So in other words, area is equal to pi times 900, or some people like to say 900 pi. Now, I think we can be a little bit more precise, so I'm going to actually type that in my calculator. 900 times 3.14, and that gives us 2,826. 2,826. 2,826 what's? Well, square meters, because we were talking about meters here. All right, 2,826 meters squared. Boom goes the dynamite. We're done.